Hi, good morning. My name is Daniel Lee. Today I'm going to continue through week 2 now, looking at communication in our breakdown of our first 3-week block. So last week, one of the things that we had talked about, if you joined us, was working through this idea of understanding analog versus digital signals. Today, what we are going to do, we're going to take one step further than that, right, and start thinking about this idea of once that data is actually formatted in this way, how is it then that data actually gets sent? And for us to do that, what I want you guys to start with is by opening up Google Doc, which you can be able to access by emailing Judi directly or sending out a request to the Discord. But basically, once you guys go ahead and open up Google Doc for today, one of the first things that you'll see is just getting set up. Today, what you are going to need is your SDG STEM kit. All right, and then you'll only need the weather sensor for today. So if you go ahead and take a look at today's presentation, you'll see that there is a picture of the actual weather sensor set up in this way. And what I've done is gone ahead and just shown what you should be getting in terms of the serial monitor being used. So you'll see how in the picture, there is no OLED display screen today. There's only the information that's being given through the serial monitor. So with that being said, right, one of the big things that you guys are going to be working through today, right? So kind of going in and out of student mode and teacher mode, if you will, right? One of the things that the students are going to be doing today is kind of working through and thinking about this idea of how is it that data actually moves, right? So once these voltages, right, are turned into digital bits and bytes of ones and zeros, right? How is it that that string of ones and zeros actually is able to move from one location, being the sensor, to the actual processor itself? And for us to do that, what we want to do is we want to just take a couple of moments to kind of think about how it is that these values, as they are populating, right, in what context is it that we can actually request the information, right? So really what we're talking about here is this idea of actually communicating between any two things, right? So the same way that we talk about communicating between us as teachers to students, right, or students to each other, right, that same method of communication is being utilized, right, as an idea in this context as well. So the first thing that I ask students to do in C, right, is discuss and think about what the statement means that communication only works when the information being shared was the information that was requested, right? And really what this will do is kind of get us started into this idea of, okay, so there's different ways that we must be able to communicate then as well. And it turns out that each one of these ways of how we communicate is referred to as a transmission protocol, all right? And based on those transmission protocols, one of the things that you guys should be able to see is that how we kind of go through this idea of data being sent and how that data is being sent, right, is going to change depending on the project that is being done. So if we switch back to kind of this idea of teacher mode, one of the things that students should be able to do in this first section of A to F is kind of come up with a model that's able to state how it is that two objects, right, or two people in an analogical context might be able to talk with each other, right? And based on this idea of how they are talking with each other, when we think about this idea of the data being collected by the sensor and how it's being communicated with the processor, one of the things that students want to be able to do is answer this question of how is it that this happens, right? Does it happen at the same time? Do they do it one after the other, right? Are they kind of talking over each other while simultaneously talking as well as being able to hear? Or is it more like our human communication where one person talks, the other person listens, right? And then the other person talks and then that former person listens. So this is a conversation that students should be having in small groups, right? And you can choose to scaffold that however you please as a teacher, all right? Now kind of switching back to the student mode of things, right? As a student, now kind of going through this idea of what it is that they're observing and what it is that you're observing as a student, right? In the slides that are attached, one of the things that I've done is created a space for you to be able to upload your model. So what we'll do is during the session with everyone, that Google slide will be editable, and you'll see some examples that students put in during our session today. And then effectively, right, it comes to this last question of, does the processor itself have to actually communicate with the sensor at the same time when the sensor is communicating with the processor, right? So again, this is the idea of, is that two-way street feedback actually always necessary, right? And where is it that you see that being the case potentially? And switching back into kind of teacher mode here, right? Today's activity will take a look at both of these things as well. All right. So this is kind of like the preface activity that I'm asking students to kind of do and be able to start having that conversation as a whole. So I add this part specifically of did you know? And this is kind of where we start to break down exactly what it is that they took a look at earlier with this idea of, you know, a one-way connection, right? I tell you what to do, right? And you only listen. That's referred to as a simplex connection, right? When we have this idea that we speak in turn, right? I speak, you listen, and then you speak and I listen, right? This is what we refer to as half duplex, right? And then full duplex is this idea that I can speak while you listen and you can speak while I listen, and we can do that simultaneously at the same time, right? So that's the biggest difference between these three types of protocols. Now, many students at this point might be thinking, why is it that we actually need to differentiate, right? It sounds like full duplex can do everything we need. Albeit that might be true, right? It might not be necessary, right? So this idea of full duplex then, right? It requires you to be able to transmit more data then simultaneously, right? But when data transfer is limited, right? And you don't necessarily need to always be communicating both ways all the time, then it's not necessary to have to use full duplex. So really this becomes more a limitation about what the actual supplies are than the actual abilities themselves, right? So the fact that data transfer is something that we need to keep in mind, right? For various reasons that we'll take a deeper look at in the following weeks, such as downlinking that data to a dashboard, right? Or being able to send it through LoRa. This idea of half duplex, right, might be quote unquote good enough for us just to stream data down, but simultaneously, right, we are going to need ways to be able to communicate both ways, and having this idea of either full duplex or half duplex, right, that at one point the satellite that they have listened, right, to a command that is sent to it versus just always streaming data down in one direction. So now kind of switching back into student mode, right? If we take a look at these questions of G, H, and I, the big thing that it's looking at here is this idea now of how it is that the different ways of looking at half duplex versus full duplex might be able to allow you to look at this idea of recording temperature data, right? So in today's actual STEM starter kit, right, one of the things that you guys should have seen in the serial monitor, right, is that it brings up and populates this temperature data, right? So it would be the same exact thing as if you had the OLED, right? The reason why we're using the serial monitor, however, is because there's something specific that I want you all to observe. In the serial monitor in particular, right, one of the questions that I ask you now is to be able to determine whether each of these transmission protocols, right, are happening individually in combination to one another, right, or if it's just one or the other. Previously, for those of you guys who were with us in prior launches, you know that we had the XK07 kit. And the XK07 kit had a different kind of robot, right? So if you go back to the slides from today, right, when you look at this idea of the processor, right, this chip in the middle, right, with the haptic feedback where you can scroll, one of the things that this processor chip was different because it was referred to as the CS11, right? And it was basically a slot where you could have an SD card, right, that acts simultaneously as the processor, right, that can tell the sensors what to do, as well as receive the data that the sensors are actually collecting back as well. And this idea of what it is that the XK07 hardware is doing then, right, is simultaneously then reading and writing data. So based on the observations so far that you've seen, right, what is that we can refer to this type of communication as? And in I here, now we kind of look through this idea of, okay, well, this in particular, right, has a particular name as well, right? So this particular way of communicating, right, with this particular transmission protocol in the context of our satellites utilizes a hardware transmission known as serial peripheral interface, right? And we get this idea of SPI from the serial peripheral, right? Now, switching back into teacher mode real quick, right? This idea of SPI interfacing, right? And this idea of full duplex, right, with our data communication. When these things occur, right, one of the things that we are seeing, right, is that data is moving again in both ways simultaneously, right? So you can read and as well as write. The nice thing about serial peripheral is that it allows for you to have multiple things communicating at the same time. And then the processor gets to decide how it wants to switch on and off as to who to listen to, right? Some processors are smart enough where they can even listen simultaneously, right, to multiple sensors bringing data in at the same time. So this idea of the SD card, what it highlights is an example of this SPI. It turns out that the processors that we have are specifically using a combination of this idea of just regular serial interface, right, where you have a send and a receive line, right, and then the SPI lines are specifically for this idea where the sensor data, as it's getting organized, right, inside the processor, right, is then using some kind of generalized sync clock, right? So that sync clock in this case, right, with that did you know, right, allows for the identification of the different sensor data using master in slave out or master out slave in lines, right? And then you have a common line that connects this idea of which one it should begin collecting data from, right? So you have a way of being able to identify and start each sensor separately. That's not a part that's necessarily important for students to have to go through here, but it's a good extension activity if you so choose to as a teacher to explore. The second part here, now kind of transitioning back into student mode, is this idea of now looking through a new analogy, right? So this analogy of a living space inside of a neighborhood, right? Take into consideration the fact that you have many streets, many houses, right? How do you identify your house, right? How do you identify your living space? And further, what about all of those streets that can handle now two-way traffic, right? How do we know that the cars themselves aren't going to run into each other, right? So if we know what it is that's coming from each house and what it is that's going to each house in that way, right, we can kind of split up and utilize this analogy to think of the cars themselves as the actual data bytes, right, or the strings of data that exist that are telling us what it is that the sensors are collecting. And here, in the context of our satellite, when we communicate in this way, this is what we refer to as inter-integrated circuits, right? And it turns out that this only really needs two methods of communication, right? Two lines of communication. It turns out it's only the clock, right, that synchronizes the data, and then a singular data line that is able to both send and receive. So when we have that send and receive going on, right, one of the things that hopefully we kind of start to realize is that you can't simultaneously do both on the same line. So what this automatically kind of leads us to think about is this idea that it must be one person talking, the other listening, and then the other person talks, and then one person listens. So how is it that that works in particular, right? So if we go back to our actual analogy here, right, it's this idea that your living space is defined, right? So the same way we can define each data packet as being a specific length. And it turns out that that specific length in particular, we can define as being, right, what it is that the sensor itself is sending, right? So what the data is, and then what the data value itself is, right? And it turns out that this is referred to, right, as this inter-integrated circuitry, right, which I briefly explained previously, right? And it kind of allows for this idea of that communication, the way that it moves from source to then destination, right, is that it's constantly streaming the data until it's told to stop or to start, right? And that's where the processor is able to send a command one way, right, and then receive the other. So one of the big questions, right, that this kind of leads us to is coming to a consensus then as to whether or not this alleviates some of the issues formed before when we looked at SPI, right? So comparing serial peripheral interface versus inter-integrated circuits, right, or inter-integrated communication, both seem to have different features, right? Is it necessarily saying that one is better than the other? Or is this looking at it more so in the context of one has a specific purpose versus the other, right? Even though the two can in some ways be used interchangeably. So how you decide to use these communication methods, right, that matters. So that's the same exact conversation that you guys should be having in your groups now as you think more so about the actual satellite you are going to launch, right? And further, whether or not these communication methods exist individually or do they exist in conjunction, all right? So since our session right now is going to be kind of, you know, one way, I'm gonna go ahead and end it there. If you have questions about the actual handout itself or the slides that attach to come with it, The slides are really just a space for students to be able to input their information, right? And then just some of the things to kind of think through while they do that live. Feel free to drop a post into the Discord, right? Or directly email me at dlee@mtsd.us, all right? And all of my information is available through the Discord as well, all right? Thanks so much for joining me, and we hope to see you next time, all right?